Welcome back, ladies and gentlemen. Just making a quick little video for this little practice quiz we got. So yeah, let's take a look. Okay, in the figure, MN is perpendicular to QP, which means that we've got a right angle right there. And we also have MP is congruent to MQ, so we've got this taking place. Name the hypotenuse of right triangle PNM. So PNM is a right triangle. The hypotenuse is the largest side. That's P. And we put a little line over top of it to show it's a line segment. The legs of the right triangle PNM are the two legs that hold it up, basically the sides that are not the hypotenuse. You're looking at PN and you're looking at NM. Okay, very nice. It's okay if you were to put NP or MN, okay, as long as you got the two letters, you're fine. Now, as far as PMQ, the large isosceles triangle, remember isosceles is two sides the same, name the legs. Well, the legs are the two congruent sides. So you're looking at PM, you're looking at MQ. Okay, it's the two congruent sides. And then name the base. The base is the third side, it's the one holding it up. That's PQ. Very good. Classify the triangle by its angles and by its sides. So you're looking for two words here. First one, I have two sides the same. Isosceles. And then all the angles are less than 90, acute. Next one, all three sides, all three angles the same, equilateral. Equiangular. Triangle. Okay, equal. Two sides the same. We're looking isosceles again. The difference here is that I have an angle over 90, so that is isosceles obtuse triangle. And finally, no sides the same but a right angle, scalene right triangle. Okay, very good. An isosceles triangle is never a scalene triangle. Okay, isosceles means I have two sides the same. A scalene means none, so I can't match them up. An isosceles triangle is sometimes a right triangle. Right? If it is isosceles, that means it's 45, 45, 90, which is x root 2. I don't know if you guys ever heard of that, x root 2. Jokes continue. 11, a right triangle is never an acute triangle. If it's a 90-degree angle, it's greater than or equal to 90. An isosceles triangle is sometimes, this is a tricky one, sometimes it's equilateral. Not always, okay? Sometimes it is. Alright, find the missing angles. Alright, the big thing here is this, a straight line equals 180. So if I do 180 minus 58, I get 122. That's my angle 2 and 3. So angle 2 is 122 degrees. Angle 3 is 122 degrees. So angle 1 is up here. If this is 122, the three angles of a triangle add up to 180. 122 plus 22 is 144. Subtract that from 180. 36 degrees. There's my angle 1. Okay, just the three angles of a triangle. Same thing down here. This is 122. 122 and 20 is 142. I'm sorry, I'm getting all over the space. 180 minus 142 is 38 degrees. Okay, so a little bit of playing there. You should know a straight line's 180. 180 minus that, you're in good shape. 14, the variable expressions represent the angle measures of a triangle. Find the measure of each angle, then classify a triangle by its angles. So I've got three angles of a triangle, which all add up to 180. So 6x plus 11 plus 3x plus 2 plus 5x minus 1 equals 180. Okay, I'm combining like terms on the left-hand side. 6x, 3x, and 5x is 14x. 11 plus 2 minus 1. 13 minus 1 is 12. Subtract 12 from both sides. 168. Divide by 14. X equals 12. Okay, so now I'm getting closer. Take this 12 and plug it back in over here. 12 times 6, okay, is 72. 72 plus 11 is 83 degrees. Okay, plug in. 12 times 3 is 36, plus 2 is 38. And lastly, 12 times 5 is 60, minus 1, 59 degrees. If I add all three of these up, they will equal 180. I know I'm awesome. Okay. Number 15, find the measure of the exterior angle. The outside angle, 4x plus 8 equals the two inside add together. 2x plus 3 plus 51. Well, get all the x's on one side. Subtract 2x, subtract 2x. 2x plus 8 equals 54. Subtract 8 from both sides. 46. Divide. X equals 23. Please make sure you read the directions. Find the measure of the exterior angle shown. So plug it in. 4 times 23 plus 8. Let's see here. 4 times 3, 23 is 92, 100 degrees. Okay? Make sure you read directions. It will really help you out. Okay, on the back, complete the following statements. If triangle WRD is congruent to triangle PLK, then WR, line segment WR, the first two, is congruent to line segment PL, the first two. B, if triangle BGT is congruent to triangle DSN, then angle T, which is the third letter, is congruent to angle N. And C, if triangle RHK is congruent to triangle WVO, then triangle KRH. All they're doing is rewriting this, so it goes KRH, third, first, second. Third, first, second. So triangle OWV. Wonderful. Now, much the same here, for number 17. Given that triangle ABC is congruent to triangle DEF, find the values of x and y. Well, alright, here's my x. My x is angle D. D matches up with A. So I can say that 5x plus 2 equals 87. I can solve this. Okay. Divide by 5. 17. Good. Now, here's where it gets tricky. Okay. If I want to find y is going to be C. C matches up with F. I don't know what F is. Okay. But I do know this. If this is 87 degrees, this must be 87 degrees. 42 plus 87 is 129 degrees. 180 minus 129 is 51 degrees. So that means that F has to be 51 degrees. So you have to do a little sleuthing first. Well then, all I got to do is say 3y equals 51, divide by 3, y equals 17. Cool. So 17, 17. Huh? Alright, for number 18, this is our last little bit here, last little hurrah. Decide whether enough information is given to prove that the triangles are congruent. If there is, state the congruence postulate you would use. So you're looking for common trends. Here's a common side for the first one. So I know that they share that. Now, again, here's my triangle. I've got a side, an angle, a side. Because if this is 90 degrees, this must also be 90 degrees. And you're only looking at one of the triangles. So S, A, S. Postulate. Okay, wonderful. For part B, they share this side in the middle. But be careful. I've got an angle, I've got a side, but please note where it's at. The angle is not in between them. This is that ASS, or SSA1 that we can't use. So this is not enough information. It could be congruent, but we don't know. Part C is everybody's favorite. Common side, 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 side. Okay, good. Part D, now I've got the angles on the outside. If this is 90, that's 90. And they also have this. All right, well, I've got an angle. I've got an angle. I've got a side. A, S. All right, part E. In the middle, I've got vertical angles. All right, vertical angles there across from each other. So now take a look. If I cover one of these up, I've got a side, I've got an angle, I've got a side, SAS. That one works. And then finally, I have an angle here, okay, from vertical angles, right? And I also have, let's see here, a side. Now the problem with this one is, again, look where the angle's at. The angle is not in between them, okay? So because of that, this is that ASS or SSA, which is not enough information, okay? Just a little heads up, I know I have the angle side here. There's one that's angle side angle. So just an example of angle side angle would be an angle, a side, and an angle. This is your ASA postulate. Okay, if you want an example to have on your notes whenever you take a look at it. So keep up the good work. As always, good luck.